Hello and welcome back to Math with Mrs. Becker. Today we are looking at other types of functions in pre-calculus. We will actually spend 3 days in this section. That way we can focus on one type of function each day. Today we will look at absolute value equations, tomorrow radical equations, and finally, to finish 2.4, we will look at fraction equations. Like linear and quadratic equations, other types of equations can be solved using algebra. Okay, so when we tried to solve linear equations, you used opposite operations until you were able to isolate the variable. With quadratic equations, that's where we use techniques such as completing the square and using the quadratic formula and factoring. Okay, this section is going to outline different procedures for solving absolute value equations today, and radical equations. How do you solve those? And what do you do when your whole equation is a fraction? Okay, so that's what we're going to look at this section. So without further ado, let's go ahead with today's skills. Absolute value equations. Remember, absolute value bars look like this. And what they represent is the distance from 0 on a number line. Okay, so if you go ahead and think back of like the old number line that you looked at in elementary school, your positive numbers go to the right, your negative numbers go to the left. Now, when you're talking about the absolute value, you're saying how far, what is that distance? How far is that number from 0 on a number line? So 2 and negative 2, they have the same absolute value because 2 is 2 units from 0 on a number line. You're going to the right. Negative 2 is 2 units from 0 on a number line. You just travel to the left, but they both are the same distance from 0. So what we need to realize is that we can travel to the left. Those will be negative values, and we can travel to the right of 0. Okay? Equations only represent moving to the right. So when we drop the absolute value bars, okay, so what we're going to have to do here is take an absolute value. This is just indicating one direction. So we need to show that we know this is actually two different equations. One equation is representing traveling to the right. The other equation is representing traveling to the left. So let's go ahead and do this. When you drop the bars, if you keep everything the way that it is, this means you're traveling in the positive direction. So it's positive. You just kept it. We're going to the right. Now, when I drop the bars, if I'm going to the left, I'm going the negative direction. Now you solve for the variable. Well, here, x is already by itself. To get rid of a negative, you divide both sides by -1, so x equals -8. So my two solutions are +8, -8. Here's again. First one, drop the bars, don't change anything. By not changing anything, we know that this was a positive out front. Okay, so we were going to the right. Now here, negative, this is 2 terms. So this has to go in parentheses. This negative would go to both, making it -x plus 4 equals 8. Now we go ahead and solve. So again, this was a positive because we're going in the positive direction. If I distribute a positive sign, it doesn't change anything. Negative indicates we're going in the negative direction, which is the left. I had to distribute because what I had in my absolute value bars, it was more than one term. Now here, I go ahead and I add 4. 8 plus 4 is 12. Here, if I minus 4, -x equals 8 minus 4 is 4. Divide both sides by -1. +4 divided by -1 is -4. So those are your two answers. Okay, one more like this. Step 1, your first equation, you drop everything. This indicates that you're going to the right. To show that you're going to the left, it's a negative out front. Drop the bars. X minus 3 equals 5. This negative has to go to both terms. So -x plus 3 equals 5. Now you solve. So here I would add 3. 5 plus 3 is 8. Here I would minus 3, so -x equals 5 minus 3 is a 2. If I divide both sides by -1, x equals -2. Okay, so that's the process that we do. Just realize that the first one, you drop the bars and nothing changes. That's going to the right. The second one, to show that you're going to the left, you would distribute a negative into whatever was within the absolute value bars, and then you could go ahead and solve. Okay, so let's keep going. It is possible to find solutions that really do not make the original equations true. Now remember, that is the actual definition of a solution. A solution is a value where if you plug it back into the original problem, you get a true statement. Well, there are times where we might mathematically do everything correct. You did not make a mistake. You found a solution, but when you put it back in, it doesn't work. So what we have to do is eliminate that solution from our solution set. Such fake solutions are called extraneous solutions, because extraneous solutions may occur when you solve absolute value equations. Once you find your solutions, you want to check them by substituting it back in and make sure that you get a true solution. Okay, so we're going to go ahead and look at some problems where we're going to mathematically do everything right, but those answers just, they don't work. Okay, step one, it's absolute value, so you have to realize that you can travel to both the left and the right. Drop the bars, don't change anything. X plus 4 equals 5x minus 2. There's one equation. That's going to the right. Now the other one, the negative, I'm going the negative direction. That negative only applies to whatever was within the absolute value bars. This negative goes here, so negative x minus 4 equals 5x minus 2. There are my two equations. Notice the 5x minus 2 did not change for either. What happened is I kept this positive, I'm going to the right. I made this negative because I'm going to the left. You cannot have x's on each side. So if I minus an x, I would have 4 equals 5x minus x is 4x minus 2. If I add 2, I would have 6 equals 4x. If I divide by 4, 6 divided by 4 is 3/2 or 1.5. So there's a solution. Here again, I do not want x's on both sides. So I add x. Negative 4 equals 5x plus 1x is 6x minus 2. Add the 2 over. Negative 4 plus 2 is negative 2 equals 6x. Divide both sides by 6. So x equals negative 1/3. Now what we have to do is make sure that these things work. Okay, so if I plug 1/5 in for each side, so I'm going to go ahead and do this in a different color when I go ahead to check. Okay, so if I go 1.5 plus 4, it's 5.5. 5.5, the absolute value. How far is 5.5 away from 0 on a number line? 5.5 units. Now let's go ahead and put that in here. 5 times 1.5 minus 2. I get 5.5. This is a true statement, so yes, that solution is great. Okay, this checks. Now I go ahead and put in negative 1/3. So if I go negative 1/3 plus 4, I get 3 2/3. The absolute value of 3 2/3 is 3 2/3 equals, now if I put it on the other side, 5 times negative 1/3 minus 2. I get negative 3 2/3. So when I fill this in on this side, I end up with a negative value. This does not have an absolute value around it, so I can't change it to a positive. These two values they're not the same thing. They're not a true statement. So this is called an extraneous solution. You have to eliminate it. Our actual solution to this problem is 1.5, or if you kept it in fraction form, 3/2. Okay, let's do a few more questions. Same thing here. If you are solving, step 1, drop the absolute value bars and don't change a thing. We're keeping it positive because we're going to the right. Step 2, realizing, okay, I might be traveling on the number line in the negative direction. So I put a negative there. The negative goes to anything that was in the absolute value. Negative x minus 3 equals 4x minus 1. Now what I have to do is solve. I cannot have x's on each side, so I'm going to go ahead and minus x. So 3 equals 4x minus x is 3x minus 1. If I add 1 over, it's 4 equals 3x. Divide both sides by 3, so x equals 4/3. Here, I cannot have x's on both sides. So if I add x on this side, negative 3 equals 4x plus 1x is 5x minus 1. Add 1 over. Negative 3 plus 1 is negative 2 equals 5x. If I divide by 5, x is negative 2 fifths. So those are my two solutions that we found mathematically using correct skills. Now let's check and see if they are correct. Now remember on your calculator, you do have a fraction bar. It's this a, b/c. And when you're entering a fraction, you hit the numerator, the number on the top, fraction bar, then the denominator. And that way your calculator knows that you're doing a fraction, okay? So here, 4, fraction bar 3. That means 4/3 plus 3. The absolute value of 4 1/3, how many units is that from 0 on a number line? Well, 4 1/3. So 4 times 4/3 minus 1. 4 1/3. This checks 4/3 is a solution, okay? Now let's go to the other one. Negative 2 over 5 plus 3 is 2 3/5. That is 2 3/5 away from 0 on a number line. Okay, so the absolute value would remain 2 3/5. Now put the negative 2/5 in. 4 times negative 2/5 minus 1. I have negative 2 3/5. Those are not the same value. That's an extraneous solution. This is our only answer, even though mathematically we found 2. Now, I don't want you to start saying, well, why are we finding 2 answers if one of them is always going to cross off? That's not the case. Sometimes they both work. Sometimes neither of them work. So it's important to find all the answers, and you just have to go back and check and see which ones work. Okay, let's go ahead and look at this. We're adding a degree of 2. So we're bringing back our techniques for solving quadratics, meaning we may have to factor here, we may have to do the quadratic formula. Step 1, drop the bars. X squared plus 4x minus 3 equals 2. Step 2, realize that this absolute value could have been going in the negative direction. Negative x squared plus 4x minus 3 equals 2. So now I go ahead and solve each. If I want this set equal to 0, I'm going to go ahead and minus a 2. So x squared plus 4x, negative 3 minus 2 more is a negative 5. I can factor this, multiply, add. 2 numbers that multiply to negative 5, the same 2 numbers add to 4. Well, that's 5 and negative 1. Positive 5 times negative 1 is negative 5. 5 minus 1 is 4. So this is x plus 5, x minus 1. To find your solutions, you take each group separately, set it equal to 0. So here I minus a 5, so x equals negative 5. Here I add a 1, so x equals 1. Now I come over to the other side. This negative goes to everything. So negative x squared minus 4x plus 3 equals 2. Now I like my first term to be positive. So even though I have more terms here, when I get it set equal to 0, I'm going to go ahead and make this side 0. So negative x squared, if I add it here, it's a positive x squared. Negative 4x would be a positive 4x on the other side. Here I would minus a 3. 2 minus 3 is negative 1. Now here, I can't factor this because there are no 2 numbers that multiply to negative 1 and add to 4. So this, my friends, we have the quadratic. A is 1, B is 4, C is negative 1. If I go b squared minus 4 times a times c, well, 4 squared is 16. Negative 4 times 1 is negative 4 times a negative 1 makes it positive 4, so that's a 20. 20 can be broken down 4 times 5. 4 is 2 times 2. So when I do the quadratic, x equals negative b, so it's negative 4, plus or minus. I can cross off 2, so 2 can come outside. I cannot cross off a 5, so it's stuck on the inside. All over 2 times a. 2 times 1 is 2. Your last step, I can go ahead and simplify this. Negative 4 divided by 2 is negative 2. Plus or minus, the 2's cancel. Square root of 5. So we have 1, 2, 3, because 1 is a plus, and a minus 4. I have 4 possible answers that we need to check. So if I go ahead and put in a negative, we need to see which ones here equal 2. So if I put in a negative 5 squared plus 4 times a negative, oh, I didn't have a squared, I had a 2 there. So negative 5 squared plus 4 times negative 5 minus 3. So that's 2. This checks, that's an answer. Let's put in a 1. 1 squared plus 4 times 1 minus 3. That equals 2. So this is an answer. Now I'm going to go ahead and go negative 2 plus the square root of 5 squared plus 4 times negative 2 plus the square root of 5 minus 3. Negative 2. So negative 2 plus the square root of 5 doesn't work because that ends up being a negative 2. Now let's go ahead and go negative 2 minus. So I'm just up arrowing and I'm changing all of the plus signs to a minus sign. There were 2 spots where I had an X, so now it's negative 2 minus. Again, this is a negative 2. Both of those resulted in a negative, so we had 2 solutions. They are negative 5, positive 1. Last question for the day, and then your assignment. There is a worksheet where you're practicing these type of questions. The worksheet is due tomorrow. Step 1, drop the bars. Keep everything the way that it is. That means that you're going to the right. Second step, if I distribute a negative into whatever was in the or in the absolute value, that means that we're going to the left. Get this set equal to 0. So if I minus 1, I have 3x squared plus 6x minus 2 equals 0. I'm just going to go ahead and do the quadratic because I do have that number in front. I can factor it, but it's kind of a long process. So a is 3, b is 6, c is negative 2. b squared minus 4 times a times c. If I go ahead and calculate this, it's my discriminant. 6 squared minus 4 times 3 times negative 2. This is 60. Well, 60 is not perfect. It's 6 times 10, 2 times 3, 2 times 5. So when I do the quadratic, x equals negative b, plus or minus, I can cross off 2 2's. That allows me to write a 2. 3 is stuck, 5 is stuck. 3 times 5 is 15, all over 3 times 2 is 6. Okay, so now when I go to simplify this, all of these values are divisible by 2. So here are your 2 solutions. Negative 3 plus or minus the square root of 15 over 3. All I did is divide by 2. 6 divided by 2 gave me that 3. 2 divided by 2 became a 1, so it can be an unwritten 1. 6 divided by 2 became a 3. So there's 2 possible answers. Now when I distribute the negative, negative 3x squared minus 6x plus 1 equals, 1. Okay, if I want to get this side set equal to 0, minus 1 and minus 1. So I have negative 3x squared minus 6x equals 0. I can factor this because this became 0. I can go ahead and take out a negative 3x. That would leave me with x plus 2. If I divide out what they have in common, they're both divisible by negative 3 and they both contain an x. So that comes on the outside. Negative 3x squared divided by negative 3x, I would just have an x left. Negative divided by negative is how I got the positive. 6 divided by 3 is 2. I had an x, I took it out. Now you take each piece separately and set it equal to 0. So here if I divide by negative 3, 0 divided by negative 3 is 0. Here if I add 2, x equals a negative 2. So now I need to check these. There's actually 4 answers here. So this is negative 3 plus the square root of 15 all over 3. Then it's negative 3 minus the square root of 15 all over 3. So if I go ahead and I plug this in 3 times, it's negative 3. I'm going to do a separate set of parentheses here. So there's the top. Negative 3 plus the square root of 15, that's the top, divided by 3, close it, to the power of 2, plus 6. The top, negative 3 plus the square root of 15, there's the top, divided by 3, close it, minus 1. We have to see if that's a 1. That is a 1. Oh my gosh. Okay, so that worked. So now I need to change the sign in between the -3 and the +2 a minus. So you can up arrow. I want -3 minus the square root of 15. I really didn't know if that was going to work. This is a lot of stuff to enter. -3 minus. There was 2 places here where I had an x. I changed them both. Hit enter. Oh, I get a 1. So one of the answers is -3 plus the square root of 15 over 3. When I changed it to a minus, when I had -3 minus the square root of 15, I'm going to make sure I have it on both of them. Yep, what happened is whoa. That is a 1 as well. Hold up, that's what we need it to be. Okay, sorry, I'm getting ahead of myself. I did get a 1. We need it to equal 1. So now I'm second guessing myself. I'm going to go back and check the plus sign. I just want to make sure I don't. Yeah, it's a 1. Okay, so guys, both of these worked. So -3 minus the square root of 15 over 3 works as well. So those two are answers. Now let's try a 0. This will be much easier to enter in. 3 times 0 squared plus 6 times 0 minus 1. Well, it's a -1, but that is in the absolute value symbol. The absolute value of -1 is +1, so this works. Now let's put in a -2. 3 times -2 squared plus 6 times -2, here we go. 3 times -2 squared plus 6 times -2 minus 1. I get -1, but that is inside the absolute value. So you guys, this time we found 4 answers. None of them are extraneous solutions. They all work. Yay, you have 4 answers. I hope you had a good time today. You have a worksheet that is due tomorrow. Talk to you later.